Hi, my name is Eric Turner, and today I will be presenting to you fuel cell technology. The reason why I chose this topic is that I currently study environmental science, and this is an issue that comes up quite frequently. And we're always having class discussions about different forms of alternative energy, and I've never really researched fuel cells, so here we go. Right here, here's a list of topics that I'll be talking about. We're going to discuss the history, electrolysis, the different types of fuel cells, the benefits, and the current initiatives. Moving on. Here's a very brief history. Fuel cells didn't really come around until like the early 1800s when somebody theorized, the possibilities of it. It wasn't until 1839 that Sir William Grove actually took it out of theory and physically built something. And it wasn't until the 1960s that NASA was interested in the fuel cell technology versus other alternative energies at that time to power their spacecrafts. Here's an image right here of Sir William Robert Grove to the left, and to the right that is the Apollo mission of 1968. So here we have this is the very basis of the fuel cell. We have electrolysis. And pretty much what you are seeing is that you have a battery source, and the terminals are connected to the anode and the cathode. And this delivers the power, and it's in a water solution, aqueous solution, and it disassociates the molecule of water, which is H2O. So we have two hydrogens and one oxygen. If we take that concept and put it in reverse, what we have here is the basis of a fuel cell. So we have the hydrogen entering the fuel cell, and the catalyst, it's going across the catalyst, the electrons being stripped away from it. The hydrogen molecule, the atom, is going through the membrane. The electron follows the circuit, the current circuit, and then it rejoins with the oxygen molecule and the hydrogen molecule to produce water again. So the only two byproducts here are heat and water. There's 5 different types of fuel cells. The first one that we're going to discuss is the alkali fuel cell, and this is actually the one that they used on the NASA, the Gemini, and the Apollo missions. The only difference here is that they're all pretty much the same, but they have a different catalyst, so I'll probably go through it pretty fast, that way it doesn't sound too redundant. But here they have a compressed hydrogen oxygen fuel that enters the fuel cell, and then it strips the electron and creates the current, and the byproduct again is heat and water. The efficiency of this one is 60% efficient. The only issues with it is that, one, it's only stable for 8,000 hours. For something to be economically viable, it needs to be for at least 40,000 hours. It's easily poisoned by CO2, and what that means is that the CO2, it blocks the catalyst sites on the catalyst for the hydrogen molecule, so the chemical reaction doesn't occur. The proton exchange membrane. This is another type of fuel cell. The same concept. It has its electrolyte, its catalyst is actually a thin permeable a polymer sheet electrolyte. It's very efficient also. As you can see, it produces between 50 and 250 kilowatts of electricity. That's pretty good. Its operating temperatures are between 50 and 100 degrees Celsius. Some of the disadvantages, again, it's sensitive to fuel impurities, so everything has to be refined, and that costs a lot of money. And another disadvantage is that the catalyst here, it's a platinum catalyst, and those are very expensive. But on the other hand, the advantages are quick startup time, it has a low temperature. The next fuel cell is the phosphoric acid, and its electrolyte is, of course, the phosphoric acid, and its efficiency is 40%. Operating temperatures between 150 and 200%. Again, the disadvantages are the high temp, the long startup time, and the cost of the platinum catalyst. The next type of fuel cell is the molten carbonate fuel cell, and this one here has a very high operating temperature. As you can see, it's 650 degrees Celsius. So what they can do with that, it's called a combined heat and power, and they can take that energy that otherwise would be lost, and they can harness that energy and transfer it into something more useful. Some of the disadvantages, again, is extremely high temperatures, so its source of application would probably be limited to that, especially in vehicles, because I couldn't imagine somebody wanting to sit on something that's 650 degrees Celsius. This one has a long startup time, but it's very durable. And this one here is actually, it's particular, they would use that for electricity generation for probably entire developments and households. The solid oxide fuel cell here, it has a hard ceramic oxide electrolyte, and this particular unit is 60% efficient, so it has a very high efficiency rating. Again, the disadvantages are pretty much the same, and the advantages are the fuel flexibilities. That's the plus, because it's operating at such a high temperature that it's just going to combust whatever's in the fuel. It doesn't matter, it's going to combust. A lot of these efficiency ratings actually I got from the U.S. Department of Energy. As you can see, if you can zoom in on that, I don't know how blurry it is. Let's talk about some of the pros of fuel cells. It eliminates the greenhouse gases, as we discussed, that the only byproduct are going to be heat and water. It eliminates the pollution caused by burning fossil fuels, which that's a plus. It has a higher efficiency than diesel or gas motors. Gas motors, of course, they're only about 25% efficient, so that's really good. Some have low heat transfer, it'd be ideal for military applications, and they operate silently in comparison to combustible motors. Some of the cons would be reforming is technically challenging and not environmentally friendly. Pretty much is that we don't have the infrastructure that's necessary, to make this economically viable currently. The driving range is shorter. That's because pound for pound, hydrogen, they just can't compress it down far enough to get us to the same driving distance as a vehicle. Also, 95% of hydrogen is produced from fossil fuels, so that's another environmental factor. Extracting that's going to cause damage. Some of the initiatives we have here are the automobile industry. We have an alliance between Ford, Daimler, and Nissan. And by 2017, they predict they'll have a car that's a crossbreed between a fuel cell and electric that would be economically viable for for just the common person to own. Currently, here's an example of fuel cells powered outside of Google's data center. You just add or remove cells if you need more or less electricity. For residential homes, currently the cost is around $50,000, so it's really a little too expensive for most people. And then we're going to have a quick recap here. So we just need to know it was created in 1839. There's 5 different types of fuel cells. It works electrolysis in reverse, and the only byproduct are heat and water. And here are my references. Thank you for watching.